Well, welcome back, everybody. I hope you're doing well today. I have been under the weather for a week or so, but now I'm feeling better, and I wanted to follow up on the first part of this video where I showed how to use ZL Stream to capture lists of notes. Those notes then could be played by a arpeggiator that we built, and the also used a menu down here to store those arpeggiations that we liked and we wanted to keep in this little menu. So I'll go ahead and turn on the Metro here. And as we play on the keyboard, it grabs those last four notes. And it also puts it in this list. And if we like that one, we can click that button there to bang, and now we have it in our list of favorite chords that we want to arpeggiate. So anyway, that was just a very simple way to show you how ZL Stream works, and just some different ideas on how you could use things for unconventional purposes like this this menu. And of course, we did build a little small sawtooth voice down here so we could listen to that arpeggiator. But the real reason I went down this path was to illustrate how to use signals for timing. So, this first example just uses this Metro, and, it just sends out bangs. So I'd like to do something a little bit more complicated and show you how to use signals into this patch. I'll incorporate it into this patch. So let me make a little bit of room for myself. I don't think we need a huge keyboard anymore. So I'm going to just get rid of this Metro, and to use a signal I'm going to use a phasor, and the phasor is going to produce a ramp from 0 to 1. It's just going to be a linear ramp. So the frequency, so I'll just create a little integer up here. That'll be our BPM control, and then we can just divide that by 60, and that'll give us the frequency in cycles per second for the phasor. So let's just look very quickly using a scope, and we'll set our frequency up to 95, let's say. So you can see the phasor going from 0 to 1, and it's doing that at 1.5-ish times per second. So let's think about how we can turn that into our patch that we already have. So what we need to do is we're going to write a little bit of gen. So I'll create my gen patch, and what we're wanting to do in this patch, we're going to get that signal that is the ramp, and I would like to send out a pulse of a sample, just one sample long pulse, whenever that ramp flips. In other words, when it goes from 1 back down to 0 again, where it starts its next cycle. So the way I'm going to do that is I just need to compare the current signal with the previous sample. So I know I have to keep a previous sample, so I'm going to go ahead and wire that in. So I just will use minus, and I'll subtract the current signal with the previous sample, and then that should give me the difference between those two. I'll just use absolute to get rid of the sign, be a positive value. So if the difference between those is big, then that means we've just hit 0. If in other words, the ramp is just finished. If it's small value, then it's just climbing up the ramp. So I really just want to compare to see if the difference is greater than, just say, 0.5. It's a big number, but it's not that precise. It doesn't matter. So if it is, then that means that's the one sample that is representing the flip from the value of 1 to the value of 0 in the incoming signal. So we're just going to send a pulse out from that. All right, so we'll hook our phasor in there, and let's just look at it through the scope again, and you see there's our pulses coming out. It's going to pulse once per beat. So now that we have these pulses, we can use a regular max object called edge. And edge will look for that pulse, and it will output a bang. So I can just stick that in there, and now we hear off. I'll set the frequency to 0. I'll just create a message up here that I can use to turn off the, and I'll create another message to turn it back on again, and I'll just set 90. So now we have our signal going through the same as we were doing before, but you might not be seeing a whole lot of advantage from this. So let me do one other thing first, and I want to add just a click so we can hear the downbeat a little more clearly. Let's see what that sounds like. No, that'll be okay. Okay, now I want to stop here, and I forgot to mention that I wanted to recommend this book, which is called Generating Sound and Organizing Time. This is where I learned about gen, and that book is about gen primarily. And it also comes with a lot of helper patches that you can use in your own patches. And the technique that I was explaining just a second ago here in the gen patch, I got that straight out of that Generating Sound and Organizing Time book. They write a much more robust and better reusable kind of patch, but I understand it well enough to understand what it's trying to do, and I sort of have a simplified version of it here. But this book is a great book, and if you have those patches that are part of that library, you can use them in your own patches, and it's a lot of interesting things you can do with signal manipulation. So the problem with using bangs, now that we're needing to do something a little more sophisticated, the problem with using that for your master tempo is that a bang just comes out of the blue, and there's a bang. You don't have any idea of the progress of time between the bangs. That's why, like a tap tempo instrument, you have to tap it a few times before it can kind of hone in and learn the tempo you're wanting, because it doesn't know. The taps just come out of anywhere. So, but the thing about a phasor signal, which is what we're using here is that you can determine at any point in time how far along you are in that beat. So if you need eighth notes, then you know that when that control signal goes from 0 to 0.5, that's halfway to the next beat. So if you were doing eighth notes, that would be when it would play. You can easily double the frequency by multiplying and wrapping the result. So what I'm going to do is I'll create another gen. We'll run our same master phasor into the gen, and let me get rid of this stuff. We're going to do, first we're going to need a parameter that we're going to pass into this this patcher, and so I need a parameter to be injected into this gen patch. So I'm going to do that by creating a parameter, and I'm going to call the parameter mult, and I'm going to let it default to 1. So let's go to the whiteboard and let me explain very quickly how this way of multiplying and wrapping phasors works. Okay, so you know, if this is 0, let's say, then our signal, our phasor signal, is going to be looking like this. And where this is 1, the top goes from 0 to 1, and then the distance along the time axis here is whatever our beats, you know, how many beats per minute we're set for. So if we look at a ramp, a single ramp, and a little bit more zoomed in, if this is the beginning of the ramp, and this is the end, and another ramp starts right after it. So if we multiply this ramp, then what we're doing is we're increasing its slope. We're making the angle here, we're making it be steeper. So if this is 1, then I can multiply it by 2, and this is the ramp that I'll get. Right, so this is twice the slope, or I'm sorry, twice the height here at each point along the ramp. So if we now, after having multiplied this by 2, if we wrap it between 0 and 1, so what that basically means is we let it go up until it gets to 1, and then we force it back down to 0. We wrap, and then it continues climbing up from there until it gets ultimately to this same point, which is where the original phasor ended. So what we've done is we've created 2 ramps inside the original ramp. I don't know if that helped at all, but that's kind of the gist of it. Okay, so here we are back at our gen patch. Remember, this is the gen that's not the beat, every beat. This is the one that's going to be multiple beats depending on the multiplier. So what I'll do is just like we discussed in the whiteboard, I'm going to multiply it by our multiplier. So that could be 2, 3, 4, whatever. And then we're going to use the wrap object to wrap between 0 and 1. So it's all built in. Now we have a value that is our it's a phasor output, but it's also mult times faster than the original. So we still need to detect when it does that change. So we'll do that the same way as we did before in the other gen patch. We'll keep a history and we'll just get the difference between the value of our new phasor and what it was previous sample. And then we will just compare for greater than 0.5. And that will go out. Okay, so we will hook up our edge like we did in the other. And now we will start driving the Arpeggiator from by the multiplier. Now let me go ahead and grab mult out of there. This is one of the great things about Gen, is being able to hook up these params like this, and then you've got a UI for them ready made. So let's go ahead and start, and not getting anything. Is that the absolute value? No, I didn't. I needed to use the absolute value of that difference. Now we should be okay. So, yeah. Okay, so now we are basically doing the same thing that we were doing with just the one metro and the banks, except I can change this parameter now and have multiple notes played by per beat. So there you go. That's kind of neat. You can, we could dress this up a little bit. Let's see. Maybe we could do something like every beat will come up with a random multiplier. So I'll do a random 4, and this is our beat bang. So I'll come up with a random number between 0 and 3 inclusive, 0, 1, 2, or 3. And I will, let me see, I want to do the power of 2 to the nth. So I want, what comes out of the random is the exponent, is the y. So I really am going to say t2i. And then the integer goes into the exponent, and the 2 goes into the x field. And then that is the value for mult. All right then. Hopefully that's helpful. And I hope you can see that you can do all kinds of things with this way of using signals. The way I've got it set here, I'm using these values. It's going to be 1, 2, 4, or 8. But you can do stuff like you can set your multiplier to be maybe 2.7. So I mean, these don't have to be. Of course, it restarts that pattern each beat. It's interesting. You might find some musical purposes of your own where you can use this technique to do micro timing and Euclidean textures and that sort of thing. Not going to get all of that here. I just wanted to wrap up this video so we can put a bow on this particular topic that I started in the last episode. So anyway, hope that was helpful, and we'll see you again next time. Thanks for watching.